Welcome to Get It Trigger. In this video, I will explain the equivalent circuit of transformer. Already we have completed part 1 and part 2 class of equivalent circuit of transformer. In the part 1 class, I have explained the shunt branch parameter. In the part 2 class, I have explained the equivalent circuit considering only the resistance of the transformer. In the part 3 class, I will derive the equivalent circuit of a transformer considering only reactance of the transformer. If you missed the previous two video, please go through that video. In this video, I am also giving the link in the description. Finally, in the part 4 video, we will learn the complete equivalent circuit of the transformer, which is coming next. Before starting the equivalent circuit, I want to explain one basic concept of flux. There are two types of flux. One is leakage flux, phi of L, and another is mutual flux, phi of M. Now, what is leakage flux and what is mutual flux? First, we should understand this. Suppose this is a transformer. This is primary winding and this is secondary winding. Now, the flux which links both primary and secondary winding. This is the primary winding and this is the secondary. The flux which links both primary and secondary winding, this flux is useful flux or working flux is called as mutual flux phi of M. Now, some amount of flux which is coming outside from this coil primary winding but does go to the air and returns back to the again primary winding. Again, some of the flux which come from the secondary winding go to the air and returns back to the secondary winding but not the primary winding. These two flux is called leakage flux. The flux which links only primary winding or only secondary winding but not the both is called the leakage flux. If the load current is I of L, then the leakage flux phi 1 L and phi 2 L depends upon the load current I L. Since the load current is not the fixed, it depends upon the load. Therefore, leakage flux is also not fixed, it is a variable. Very important point to be noted, leakage flux is variable and leakage flux does not transmit any power from primary to secondary. Another point, the leakage flux is in phase of respective load current, whereas the mutual flux phi of M depends upon the supply voltage V. Mutual flux depends upon V. Since supply voltage V equal to constant, therefore mutual flux also is a constant term. Now, consider a transformer. This is the primary winding, this is a secondary winding and this is the core of the transformer. Whenever I apply a AC voltage V, then since no load is connected here, it is open circuited, then a small amount of current, no load current I0 will be drawn from the supply. I0 has two components, IW working component plus of magnetizing component I of mu, which has been explained in the part 1 video. Okay, please go through that video. Due to this magnetizing current I mu, a flux will be produced into the primary winding, and this flux will passes through the core of the transformer and link with the secondary winding and returns back to the primary winding. This flux is phi. Now, whenever a load is connected to the secondary of the transformer, then a current IL, load current, will start flowing through the transformer secondary current, secondary winding. Now, due to this current IL, a flux will also be produced. Now, the flux direction is so that it will try to oppose its causes, and its cause is the main flux phi. Therefore, the direction of the flux phi 2m will be opposite of phi, in this opposite direction of phi 2m. Now, since the phi 2m, due to the current IL, opposes the main flux phi, therefore net flux phi net will be phi minus phi 2m. Therefore, net flux tends to reduces. As the flux tends to reduces, therefore the induced EMF E1 also tends to reduces. Again, E2 induced EMF also tends to reduces. In order to make E1 equal to constant, an additional amount of current is drawn from the supply I2 dash. Now, this I2 dash will again produce a flux which will oppose the phi 2m and in same magnitude of phi 2m. Due to that means due to I2 dash, a flux will be produced. A flux will be produced, passes through the core. Actually, it should passes through the core. There is no space here, therefore I draw the outside. Okay, this flux is the phi 2m dash. Okay, now here phi 2m dash will be minus of phi 2m. Magnitude is same but opposite direction. Therefore, the net flux here it becomes phi minus phi 2m plus phi 2m dash. Now, since these are equal, therefore these two terms will be cancelled out. As a result, phi working flux will remains constant, E1 will be constant, E2 will be constant, and transformer works properly. Again, due to IL, load current IL, a flux will be produced into the secondary winding, but it comes outside in the air, again returns back to the secondary winding. This flux only link into the secondary winding is called leakage flux phi 2L. Phi 2L is the leakage flux and phi 2m is the mutual flux. Similarly, due to the current I2 dash, besides of flux phi 2m dash, this is also mutual flux, links both primary and secondary. A flux will be produced which comes outside in the air gap, again returns back. This flux which links only the primary but not the secondary is called again leakage flux phi 1 into L. This is also leakage flux. We can say that current IL produces flux phi 2 which has two components. One is the mutual flux phi 2m, another is a leakage flux phi 2l. Due to the leakage flux phi 2l, a leakage inductance will be there. L to L is given by N2 into phi 2l divided by I2. Due to this leakage inductance, a leakage reactance X2L will be given by 2 pi f into inductance L2L. This is the X2, that is equal to leakage reactance of the transformer secondary winding. This is the leakage reactance of transformer secondary. Similarly, due to current I2 dash, a flux phi 1 will be produced. Now, phi 1 has two components. One is phi 2m dash, opposition of phi 2m, dash, and another component is the leakage flux phi 1l. This leakage flux phi 1l. Due to the leakage flux in the primary winding, there will be leakage inductance will be given by N1 phi 1l by I2. Since all of you know L equal to N phi by I. Due to this leakage inductance, the leakage reactance Ix1L will be given by 2 pi f L of 1L, that is equal to x1, that is called leakage reactance of transformer primary. Leakage reactance of transformer primary. Do the correction. This is the current I2 dash, not I2, since this flux is due to I2 dash. Now, if we draw the equivalent circuit of transformer due to reactance, then this is the X1 primary winding reactance, and this is the transformer
This is the reactance. X2 is the secondary winding reactance. Now load is connected here and we apply a supply voltage, AC supply voltage V here. This current is the I2 equal to the load current IL, this load current IL. This is a secondary induced EMF E2. Primary induced EMF is the E1 and the primary current is I1. Now if we transfer the secondary winding reactance into the primary side, then it becomes X2 dash. This is the X2 is transferred here, it becomes X2 dash. X2 dash is the secondary winding reactance referred to primary. Now primary winding has N1 number of turns and secondary has N2 number of turns. Therefore, in the equivalent circuit of second part of video, we have learned one thing, that per unit resistance of primary is equal to per unit resistance of secondary. Similarly, here per unit reactance of primary is equal to the per unit reactance of secondary. Here per unit reactance will obtained by current is I1, reactance is X2 dash divided by induced EMF E1 equal to, here current is I2, reactance is X2 and induced EMF is E2. From here I can write down X2 dash equal to E1 by E2 into I2 by I1 into X2. As we know, the voltage ratio E1 by E2 equal to the current ratio I2 by I1 equal to turns ratio N1 by N2. Therefore, from here, using this formula, I can write down X2 dash equal to N1 by N2 L square into X2. This is one of the important formula. You have to remember this. The secondary winding reactance referred to primary, that means X2 dash equal to the N1 by N2 that is square into secondary winding reactance X2. Therefore, we can draw the equivalent circuit as like this. This is the X1, this is the X2 dash, X1, X2 dash, this is the transformer, like this. This X1 plus X2 dash is together called it X01. Therefore, total reactance of transformer referred to primary is given as x1 plus of x2 dash, that is equal to x of 0 1. Therefore, the per unit reactance of transformer with referred to primary is given by per unit reactance of transformer primary is given by total per unit reactance is given by current. This current is I1 and this induced EMF is E1 and total reactance is X01, that is given by I1 into X01 divided by E1. Therefore, percentage of X or percentage of reactance drop will be I1 into X01 divided by E1 into 100%. This is another important formula. You have to remember this formula. This is the percentage of X or percentage of reactance drop with respect to primary. Again, the circuit of transformer, the considering only reactance is given by this is the primary reactance X1, this is the secondary reactance X2. Primary induced EMF E1, secondary induced EMF E2, primary number of turns N1, secondary number of turns N2, the secondary current or load current is I2 and primary current is I1. Now, if I transfer the reactance X1, primary reactance X1 into the secondary side, then it becomes X1 dash. Therefore, again the per unit reactance of primary is equal to per unit reactance of secondary. As we derived earlier, it will be the secondary winding current is I2 and reactance is X1 dash divided by E2 will be the primary winding current I1, reactance X1 and induced EMF E1. We can write down X1 dash equal to E2 by E1 I1 by I2 into X1. Since this is equal to N1 N2 by N1 and this is equal to again N2 by N1. Therefore, we can write down X1 dash equal to N2 by N1 square into X1. This is again one of the important formula. You have to remember this formula also. So we can write down the equivalent circuit of transformer considering only reactance referred to the secondary side is given by this is the X1 dash, this is the X2. total is X02. Here X1 dash is the primary winding reactance referred to secondary. Therefore, total reactance, get down, total reactance referred to secondary is equal to here X1 dash plus X2, that is equal to X02. Total X1 dash plus X2 equal to X02. So therefore you can write down total per unit reactance with respect to secondary. Total per unit reactance drop with respect to secondary is equal to the current here, secondary current is I2 and induced EMF is the E2. Therefore, I2 the total reactance referred to secondary, that means X02 divided by induced EMF E2, and percentage of X or percentage of reactance drop is given by I2 X02 by of E2 into 100%. This is the formula. Again you have to remember this one. This is the with respect to secondary. Thank you watching my video. Please subscribe my channel and share the link to all of your friends so that you don't miss any important videos. I will try my best to upload most important videos which will be very useful for you. Thank you once again.